Hey everybody, just want to share some stuff about parallel circuits. First of all, before we can get started with this sheet, what I want to do is I want to go ahead and put the Ohm's law triangle on here because we're going to use that over and over and over again. So we have voltage, current, and resistance. Okay. Now, a parallel circuit, basically what you're going to do is you have your voltage here, which starts off at 6, and as it runs down and around the circuit, what happens is it's going to send 6 volts down each branch, kind of like this tree up here. As it's coming down, I'm sorry, this water flow. As water's flowing, it's going to send equal amounts on either side. It also is going to tell something about the current of the layer. So it says by Ohm's law, what is the current each of the resistors? Okay. Well, we're trying to find the amps, so we cover up our I. V divided by R is going to give our amps. So V is 6 volts divided by 2 ohms, we end up getting 3 amps. Okay. Now, keep in mind, you're going to have 3 amps basically running through here, and you're going to have 3 amps running through here. Okay. So that means we're going to have a total of 6 amps. Okay. So if we're trying to describe what's going on here in terms of the total amount of current that we have flowing, one of the things we can take a look at is this is going to be 3, this is going to be 3, because as this comes down, it's going to combine with this, that makes this 6. Okay. Remember, we had 3 coming off of this one. We had 3 entering this one. And we had 3 here. And we have 3 here. And this becomes 6. And it says right here, the sum of the current in the 2 branches has equal the current before it divides. Okay. So it kind of gives us a breakdown here. Fairly straightforward. Nothing too terribly complex. Just understand that as you're moving down each branch, they're going to have the same amount of voltage. And the resistance, then, we're going to use Ohm's law to figure out how much current is moving through each branch. All right? The next part says, cross out the circuit below that is not equivalent to the circuit above. Well, we're basically looking for a parallel circuit. So this one and A are pretty much the same. B is the same. D is actually the same as well. So the only one that's a little different is going to be C. All right? All right. Moving right along here. It says, consider the parallel circuit to the right. What is the voltage drop across each resistor? Okay. Now keep in mind, what happens to voltage? Voltage is going to be the same across each part, like I just got through saying. So the voltage in this situation is going to be what my initial voltage was, so it's going to be 6 volts. Okay. Now it says, what's my current across each of the branches? Well, I go up here and I use my Ohm's law again. I'm going to go ahead and try and find amps. So it's going to be voltage divided by resistance. Okay. So my voltage is 6. So 6 divided by 2, 6 volts divided by 2 ohms gives me what? It's going to be 3. 6 volts divided by 2, it's going to be 3 amps again. And 6 volts divided by 1 ohm is going to be 6. All right. Make sense so far? Now, the current through the battery equals the sum of the currents the current through the battery equals the sum of the currents, which equals what? Well, 3 plus 3 plus 6 is what? It's going to be 12. All right? Make sense so far? All right. Moving right along. Now, it says, what's the equivalent resistance of the circuit? Okay. Now, keep in mind, resistance, again, we can use volts divided by, I'm blanking here, volts divided by current. So if I had 6 volts divided by 12, I'm going to get what? I get 1/2. Or 0.5 ohms. And that's going to be my total resistance, 0.5. Okay, now there's another way to get this number that I want to show you real quick. And it's a little more complex, but it works the exact same way. Basically, if I'm looking for the 1 over the R EQ is equal to 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3. Okay, so if I'm plugging that number in, basically what I end up getting is I get 1 over 2 plus 1 over 2 plus 1 over 1. So 1/2 plus 1/2 plus 1 is equal to what? Okay, it's going to equal 2. Okay, because 1 plus 1 plus 1 is going to equal 2. Now, if I take the inverse of that to get, because that means that 1 over Req is equal to 2, that means the R equivalent then is equal to 1 over 2, or 1/2 again. So fairly straightforward. Hopefully this explains a little bit more about parallel. You'll have some practice you'll get to work with. As always, if you have any problems or questions, just give me a holler and I'll be more than happy to help. Thanks. Talk to you later.